Hello, listeners. As an enhancement to your listening experience, I am now going to present these archive episodes unedited in their entirety, which includes all of my afterthoughts. So, continue listening after the outro music if you want to hear what I thought of the episode. And if you are enjoying the podcast, please support it by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Thanks.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
And I feel okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 210 of the Space Rocket History Podcast. And now, Apollo 11, Mission Training, Part 2.
The flight director is given a team of between 15 and 21 controllers. They're people who specialize in trajectories and spacecraft systems. We have medical doctors, planners, facility operators. We have an astronaut who serves as the communications link between the crew and ground. Each one of these controllers, when they move into the control room itself, is expected to be able to make 100% correct calls on anything within his area of discipline, literally within seconds. Flight director's job is basically to assemble the pieces and again make the mission decision, literally in seconds. The controllers have always used a principle that I would call learn by doing. There is no piece of paper, there is no technical information, there's no schematic flight. There's nothing in this control room that was not developed by a controller. A controller in the guidance system would provide all the information on that system, and then he would hand it over to a flight planner who would use it. And the flight planner wouldn't redesign it or change it. It was basically trust in that handover that that data was correct. Then this flight planner would basically develop a flight plan, hand it to the trajectory officer down for the design of the trajectory. So each one of these controllers is totally accountable, not only for getting the job done, but for the 100%, what I'd say, perfection of the information at his console. And I think everyone knows how difficult perfection is to achieve, but in mission control, that is literally the name of the game. It's what I'd call excellence in the art of crisis management. The control team itself, and sitting in this room, basically had the responsibility for the seconds to minute type decisions. Once they moved beyond that time frame now, and we had a little bit more time to work on it, they had a support staff room. And the support staff room was basically one layer deeper, one layer more knowledgeable in specific spacecraft systems, the jobs we were trying to do. And then once we moved beyond the minutes into the hours time frame, we had hotlines out to all of the contractors where you could literally reach out and touch the individual who designed, tested, checked out, the last individual who had ever worked with a component in the spacecraft. You could go into the laboratories. It was not unusual that within hours of a problem, we would have a test rig set up in one of the contractors or subcontractors' laboratories, trying to duplicate the exact problems that we were experiencing in flight. It was really an incredible focusing mechanism for decisions that were coming at us and recommendations from all over the country.
That was Gene Kranz describing the mission control team. Now, continuing from last week's lunar module simulation training, it was very difficult for the mission controllers to master the complexity of the powered descent to the moon. It was especially tough for them to judge when the astronauts had entered the dead man's curve. Then there was the problem of communications time delay. But perhaps the most difficult problem was getting the feel of how to handle malfunctions during descent. And don't forget the added pressure of the bosses looking over your shoulder. During integrated simulations, every manager in Houston, including Chris Kraft, was listening to the audio of the simulations through their squawk boxes in their offices. After the first simulated crash, the black telephone behind Gene Kranz's flight director's console rang, and it was Kraft. At this point, Kraft was almost joking, saying, quote, "I see you guys let it get away from you," end quote. A week later, Kraft was not joking anymore, saying, quote, "What's the matter with you guys?" end quote. Krantz also felt that the astronauts were getting frustrated as well. It was hard enough just getting the complex simulator at the Cape and the roomfuls of computers in Houston to work long enough to get all the integrated simulations required in the training syllabus completed. The astronaut crew did not need a team of controllers who could not respond correctly to an emergency. Krantz was even beginning to doubt his own abilities. But let's not get ahead of ourselves. Lunar landing training kicked off officially at T-minus 8 weeks. Krantz's team, fresh from Apollo 9, had a hot hand, and in the beginning they did well. The first 2 days of training were used to nail down the timeline for the landing preparation, establish the go-no-go points, give the controllers a walkthrough of the landing sequence, and become familiar with the 3-second communications delay when working at lunar distances. Initially, the 3-second delay didn't seem like much, but if things started to go wrong in the final seconds before landing, one could find themselves in a corner of a box with no more options. The mission rules and procedures were refined during the initial 2 days of training, and Krantz felt well prepared to start the landing abort simulations. However, Krantz and the simulation supervisor, Dick Coos, were concerned about the adequacy of the training schedule. Putting all the pieces together in 11 days of training scattered over 2 months was tough. After the first 2 sessions, Coos' judgment was that Krantz's team were a little too cocky, and a bit of humility learned early in the training might make them more receptive. And Coos was just the man to do that. Mere seconds into the next simulation, Krantz's team started the descent. It seemed every controller had problems. The voice loops were jammed by controllers voicing instructions through Capcom Charlie Duke to the crew. Seconds after the crew responded, another problem surfaced, then another, until Bob Carlton advised he had problems in the ascent stage. If they continued, they'd leave the crew on the surface without a way home. Once the abort call was made and the engine throttled up, Coos called on the loop, quote, "Good one, flight, you nailed it. Let's start the turnaround for the next run," end quote. By the third run of the day, time criticality and complexity of each training run was peaking, and Krantz's team was barely holding its own. Coos was having his own problems trying to keep the simulation computers from crashing. During the 4th run, there was a crash. In the trench, Jay Green got behind on his calls, allowing the lunar module landing speed to build up. Their final instruction to abort was too late, and Fido, Jay Green's large plot board in the front of mission control, was a mute testimony to the futility of their action. With the 3-second delay in communications to the moon, the crew was splattered across the Sea of Tranquility. This was their first crash, the result of a few seconds delay in communication and decision. On the next session, crews delivered a virtual repeat of their previous crash. This time, with the crew approaching the lunar surface, the lunar module primary computer failed, while Krantz was working an electrical problem with the systems controller. The distraction caused by troubleshooting an electrical fault resulted in a late switch to the backup computer system for the abort. Krantz's team were learning the hard way about the dead man's curve, the second's critical relationship of velocity, time, and altitude, where the spacecraft will always impact the surface before the mission control can react and call an abort. In flying terms, they were behind the power curve. The debriefing was long and intense, focusing on the need for some new rules. Approaching the moon at a high rate of speed, the lunar module can go a long ways in 3 seconds. Jay Green took the action to change his mission rules and plot board limit lines to add bias to accommodate the communications delay. The next 2 simulation runs were a washout. Krantz felt like a novice flight director. But simulation supervisor Coos never backed off. His pressure was unrelenting. Krantz's team were just hanging on, and their performance was in a downward spiral. Every team member was frustrated and tried desperately to get the team back on track. Krantz had just had his worst day of simulation ever as a flight director. But when the lunar module headed for the lunar surface, Krantz would be working in precious seconds. His team had to work out the bugs now. The simulation supervisor was winning the battle, and there was little Krantz's team could do except hunker down, study some more, get more training, and come back and do it again and again. Neil Armstrong was also curious to know how Mission Control would respond to an abort scenario. One day in late June 1969, Neil and Buzz were going through the power descent simulation. Things were proceeding normally until the lunar module was close enough to look for a landing spot. Then the attitude indicator began to tumble. Apparently, a thruster was stuck on. Buzz looked out the window and saw the moonscape tilting crazily, looming ever larger. He was sure that if they continued the descent, they would both be killed. But Armstrong did not care about that during this simulation. Buzz was a little cautious about telling his commander what to do, but he finally said, "Neil, hit abort." Of course, Neil ignored Buzz. Eventually, Capcom gave the order to abort, but it was too late. Armstrong and Aldrin's simulation had ended with a crash, which irritated Buzz to no end. He believed the failure would be accredited to the crew. But Neil wasn't concerned about a simulated crash. Rather, he wanted to see how Mission Control would handle an abort situation. And he did. Mission Control was too late with the abort call. Also in June, during the Flight Readiness Review meeting, management wanted some changes with Mission Control's landing data rules. Chris Kraft and other managers were concerned that if there was a crash on the lunar surface, would there be enough data available at Mission Control to analyze what went wrong? Here's Gene Krantz commenting on the subject.
One of the mission roles, I'm talking about game plan, that was given to me exclusively, where I had to make a decision, is in the preparation for the mission. Headquarters people, the program managers, as well as Chris Kraft, was concerned that if we would crash and not have enough data to figure out why we crashed, we'd be in jeopardy of the not only losing the lunar goal, maybe the entire program. So everybody wanted to make sure that there was some formula that would be used by the team to say, okay, we got enough data to continue. I fought this particular rule because they wanted some quantified. They want some numbers with this thing. And I fought this rule all the way through the process of building the rules, going through the reviews, the mission reviews, etc. And I wanted a very simple one that says the flight director will determine whether sufficient data exists to continue the mission. And I just wanted that simple, that it was a subjective call by the flight director. And this was batted back and forth until very close to the mission. And it was not resolved, so I wrote into the mission rules that exact statement. The flight director will determine if sufficient data exists to continue.
During the last 2 weeks of lunar module simulation training, the individual and team confidence was restored due to the changes made to the procedures and the superb effort of the simulation supervisor and his team. Which brings us to the eventful last day of simulator training for Apollo 11. Usually, the final day was used as a confidence builder, with most of the training runs focused on achieving the mission objectives. However, this wasn't the case on July 5, 1969. Armstrong and Aldrin had already deployed to the Cape, and simulation supervisor Coos was running the simulation with the Apollo 12 crew. Here's Gene.
Training people, interestingly enough, as we prepare for a mission, you spend a lot of time, hundreds of hours with the crew, going through the rehearsals over and over and over and over and over, and you tend to get into routine. You tend to get into what you would say is almost perfect synchronization here. What the training people would do to us, as we were approaching the time when the crew is going to go down the Cape, and actually we're going to start the mission, they'd throw in a less experienced crew from a downstream mission. So all of a sudden we'd have to go back into the coaching mode with that team. We couldn't expect them to be totally familiar with that procedure, so we'd have to talk a bit more about it. So it was a process of the ground assuming that we had to be totally aware and on top of every exact thing the crew did. And then if the crew would then assume that the ground wasn't watching at all, you would have basically the conjunction where you probably had the best and most effective operation. So it was to the point where the crew had to be capable of doing the job, and the ground had to assume for some reason the crew couldn't get it done. So you drive for this very precise, incredible timing.
Krantz's team began the day with Pete Conrad and Alan Bean. By midday, however, their backups, Dave Scott and Jim Irwin, joined the simulation. For the final simulation, Coos gave Krantz's team something they hadn't seen before. The simulation picked up with the crew performing the final systems checks before starting the descent. Krantz polled his controllers for the start engine, go, no-go, and Charlie Duke called to the lunar module crew, "Eagle, you are go for powered descent." 5 minutes later, the descent engine started, and they were on their way to the surface. 3 minutes into the landing sequence, Coos nodded to his team. "Okay, gang, let's sock it to them and see what they know about computer program alarms." The lunar module computer provided a series of 5-digit alarm codes. The computer alarms signal crew or ground procedural errors, computer hardware or software problems, or out-of-limit conditions. In the trench, Steve Bales, the Guido, was busier than usual. He had done well so far today in training and was glad it was about to end. Steve was responsible for the lunar module computer. He had to make sure it got the right data from Earth and then had to be certain that guidance, navigation, and control functions during the landing were being executed properly. Within seconds of Coos' malfunction entry, Steve was peering intently at his television display. He was seeing a 1201 alarm code indicating a computer restart. This was the first time he had seen this code except during computer ground testing. An equally perplexed lunar module pilot in the simulator called up data on the lunar module computer display. The code was meaningless, and he decided to wait for mission control to enlighten him. At Bales' fingertips was a small 1/4 inch thick blue handbook containing a glossary of the lunar module software. Quickly paging through the index, he read, 1201, executive overflow, no vacant areas. This meant that the computer was overloaded. The lunar module computer was unable to complete all its jobs in the course of a major computer cycle. Bales had no mission rules on program alarms. Everything still seemed to be working. The alarm did not make sense. As he watched, another series of alarms was displayed. Punching up his backroom loop, he called Jack Garman, his software expert. Garman's response did not help. He said, quote, "It's a bailout alarm. The computer is busier than usual for some reason. It has run out of time to get all the work done," end quote. Bales did not need to consult the rules. He had written every computer rule, but there were no rules on computer program alarms. Where had the alarm come from? The computer on the lunar module was designed to operate within certain well-defined limits. It could only do so much, and bad things could happen if it were pushed to do things it didn't have the time or capacity to do. Staring at the displays and plot boards, Steve desperately sought a way out of the dilemma. The computer was telling him something was not getting done, and he wondered what it was. After another burst of alarms, Steve called Garman again. "Jack, I'm getting behind the power curve. Whatever is happening ain't any good. I can't find anything wrong, but the computer keeps going through software restarts and sending alarms. I think it's time to abort." Seconds later, Steve called Krantz. "Flight, guidance, something's wrong in the computer. I've got a bunch of computer alarms. Abort the landing, abort." Charlie Duke picked up on the call. "We gonna call an abort flight?" Krantz's response was curt. "Abort, Capcom, abort." If there's one word guaranteed to get your attention in mission control, it is the word abort. This word is never used casually and literally rings across the voice loops as the word is passed to the crew, computer controllers, and support personnel. An abort is an intensely time-critical effort where every action must be perfect and perfectly synchronized. In an abort, your chances of getting out alive are good if the abort is done at the right time. If you're off the timeline, your chances are not good 200,000 miles away from home. An abort is the last option, one that must be perfectly executed with perfect timing if you're going to pull it off. The crew confirmed the abort calls as they throttled up the descent engine and then staged. The ascent engine ignited, and moments later they set up a rendezvous with the command module. Krantz felt that they had made the right and necessary call, but he was really unhappy with Coos. He believed the team should have finished their training with a landing on the surface. The flight controller debriefing was extensive. After listening to the confessions of the team members, Coos gave his evaluation of their performance. Slowly, methodically, Coos took them through the problem. Then he plunged in the dagger. Quote, "This was not an abort. You should have continued the landing. The 1201 computer alarm said the computer was operating to an internal priority scheme. If the guidance was working, the control jets firing, and the crew displays updating, all the mission-critical tasks were getting done. You violated the most fundamental mission rule of mission control. You must have 2 cues before aborting. You called for an abort with only 1." End quote. Steve Bales, the proud, capable young computer whiz kid, was devastated by the simulation. The controller's world, however, It's black and white, go or no go, right or wrong. A controller can never make an excuse. His only answers when he fails are either, I was wrong, or I don't know, but I will find out. Bales was frustrated and mad. He told Krantz that he was going to pull a team together after they finished the debriefing, and then call Krantz once they had the problem figured out. Every controller has experienced the bitter taste of failure. A single busted training run is abysmal. A busted run on the final day of training is unacceptable. Slowly, Krantz's control team took off their headsets and packed up their gear. They had run the last race, and the simulation supervisor had won the battle. They would just have to get on with their job. Later that evening, Krantz received a call from Steve Bales. He told Krantz that Coos was right, and he was glad that they had the training run. The computer whizzes at MIT Labs and their own assessment said that we could have continued. Bales was going to stay with his team that night and get out some more rules. And he had already talked to Coos, and he was going to set up some more training runs in the morning. Coos scheduled 4 hours of training on program alarms the next day. The runs were scheduled with the Apollo 12 backup crew as well. The sim supervisor triggered various alarm types during several intense training sessions, while Steve Bales and Jack Garman collected computer performance data and response times during alarm conditions. On July 11th, 9 days prior to the launch, Steve Bales modified his already lengthy listing of reasons to abort the lunar landing, adding a new entry to the trajectory and guidance section of the rules. Lunar Module Program Alarms 1201 and 1202 did not require a landing abort. I've saved the last word on this episode for the Apollo 11 Lunar Landing Flight Director, Gene Krantz.
The process of preparing for a mission and executing a mission is an incredible forcing function because it requires each individual to step up to their concerns, the problems they have, the gut feelings, and make a commitment. Am I go or no go? And it starts from the lowest guy in the factory up through his chain, where again you have this kind of a decision. And there's no such thing as a perfect spacecraft. There's no such thing as a perfect mission. What you have to do, and you have to learn to make decisions short of certainty. And I believe this is how we were able to achieve the lunar landing, starting from a cold start in 10 years. We were willing to accept some level of risk to get the job done. And we believed, and this to a great extent goes back in the design, the program manager, whatever risks remained would be put on the back of mission control to find some clever way to work around that risk, to accomplish your objective in spite of a problem on board the spacecraft. So basically, our job was to, the engineers would do the best job they could. They'd hand us the spacecraft, and it was up to us to live with whatever risk remained in the spacecraft, the design of the spacecraft, the design of the mission, that type of stuff.
Salutations from the foothills of North Carolina. This is Michael Annis, your host, and I wanted to say thanks for listening to episode 210 of the Space Rocket History Podcast, entitled Apollo 11 Mission Training Part 2. I want to give a big shout out to all my longtime listeners. Thanks for staying subscribed, and extend a warm welcome to my new listeners. I'm glad you're here. Make sure you sign up for the email list and connect with me on Twitter and Facebook. You can do all that, as well as download every single episode of the podcast on the homepage, spacerockethistory.com. Today, we salute my Patreon donors. Patreon donors give a small amount monthly to support the podcast. Thanks, Patreon donors who honored their pledge this month. I had several afterthoughts about this week's episode. First, I want to give credit to Andrew Chaikin and Gene Kranz. Those were the main sources for this episode, as they were last week. I guess the mission control team and the simulation team were kind of adversaries, but they had a common goal. Simulation supervisor Coos and his team did a great job challenging Gene Kranz's mission control team, particularly in the last simulation with the computer error codes. That simulation run really paid off. So remember, 1201 and 1202 computer alarms are not sufficient to call an abort. That's good to know. It may come up again. What did you think about Neil doing his own test of mission control? I guess he needed to know how fast Kranz's team would respond. After all, he and Buzz were going to be out there sticking their necks out, so naturally, he wanted to know if he could trust mission control to call an abort or if he would have to do that on his own. I guess he found out. I know Kranz's team had it rough this episode, but consider this. They were doing this simulation for the landing for the first time. They didn't have help from someone who'd already done it. They were the ones writing the rules and procedures. And I think in the end, they did a great job. My hat is off to Gene Kranz and his team. Okay, I posted some pictures and the audio for this episode on the webpage at spacerockethistory.com. I hope you check that out. I was pleased to receive several donations to support the podcast this week. Peter H. from France donated at the Apollo level and earned his rocket emoji. Luke W.J. from the foothills of North Carolina donated at the Sputnik level. James C. donated at the Vostok level and earned his rocket emoji. Andrew W. pledged on Patreon at the Mercury level, and Eric Green pledged on Patreon at the Vostok level. Thank you, Peter, Luke, James, Andrew, and Eric. That brings the total Patreons to 113. That is 37 short of the goal of 150 before the end of the year. And our overall donors are now at 176 with a goal of reaching 300 by the end of the year. For those of you who are enjoying the content and have not donated yet in 2017, please consider supporting the podcast. Keep in mind, Space Rocket History is entirely listener funded, and I depend upon your financial support to keep the podcast going. All donors are rewarded with their name on the donors page on the website spacerockethistory.com based on their donation level. Second-year donors receive the coveted rocket emoji. Third-year donors receive the treasured moon emoji. And fourth-year donors receive the sought-after satellite emoji next to their name on the donors list. Want to encourage everyone to share the podcast. Feel free to link the homepage or a particular episode on all social media. And thanks to those who've already done so. And we will have the May retweeters by Mrs. SRH.
Hello, listeners. This is Mrs. SRH with the retweeters for May. Jet City Star, 1202 Alarm, Alki Nessoff, Andy USA 18169, Ashley James Lee, Beacon 63, Bert at Home, Bonner to You, Buddy P. Murphy, Captain Beardy, Condor's Condor, Craig Liebert, David B. Nugent, Eric Reedy, Futurama King, Geared, Indy TM42, Jacob Hahn, James 2904, Kadavi 1202, KHS Astronomy, Lawyer Yogo, Pee-wee 888, PJ Ward 58, Papillon 3033, Parkhurst P1, Mulmac, Michael Hoadley, M. Lunyon, Rapid Mustang, R. Rokins, Shinar Squirrel, Stephen Lebowski, Skibby, Sister Insight, Tardomatic, the J.R. Flyboy, This is Alex Boyd, Tromboner Man, Wayne Neville 75. Thank you, retweeters.
This is the end of content for this episode, and you are welcome to stay and listen to my off-topic thoughts if you want. Thanks for sticking around, folks. I hope you enjoyed that episode. Next week, we will hopefully finish with the special training required for Apollo 11 and then get started on the launch. In podcast news, you may recall from last week that I created a podcast store. Well, I ordered 4 items, and I have received them, and I would like to give my critique right now of those items. First was the ball cap. That really turned out nice. I liked that ball cap. That was good. Then the magnet. I ordered the magnet with the rocket lineup. And I picked the biggest one they had so I could see it well. And it looks pretty good. It could be adjusted a little bit. It needs to be trimmed up just a little bit to be perfect. But it looks pretty good. And we'll fix that thing up a little bit. We'll edit it for next time. The third item I received was the water bottle. I wasn't that impressed with it. The logo is not printed into the plastic like I thought. Instead, it's kind of a wraparound sticker like you would find on maybe a 2-liter bottle of Coke or something like that. It's kind of a sticker like that, so I wasn't impressed with that water bottle. The last thing I received was the t-shirt. I thought that really looked good. My grandson is going to give it the wear test to see how it holds up, but my first impression of the t-shirt was very nice looking. So if anyone wants to order something, you have my critique to guide you. To get to the store, you can type cafepress.com/spacerockethistory, or you can go to the home page and click on the store tab, which is near the top of the screen with the other tabs. Then click on any picture or link and it will take you to the store. In other podcast news, I have a few items from NASA that I would like to give out to the donors, a little bonus for the donors. We will have a drawing next week, and I will give out the first item. Now, it's not anything earth-shattering, okay? It's something that can be mailed easily to you, so it's not that big of a deal. But if you are a 2017 donor, you will be eligible for the drawing to receive a little something from my NASA stash next week. In other podcast news, I've been thinking of some ways to celebrate or honor the commercial flights that are going on now, such as SpaceX and ULA. On the donor page, where I have the levels of donation, I noticed that the ISS level had not been used in 2016 or 2017. So I was thinking I may move the ISS level down with the Mir level. So the $80 donation would be a combination Mir ISS. Then I could put the commercial space companies in at the $90 level. And the donors could then select which company they wanted to have their name next to, whether it be SpaceX, ULA, Blue Origin, whatever you're a fan of, you could have your name beside that particular commercial space company. Then the company with the most names could have the highest position, and the next most popular could be in the second position, making it sort of like a competition between the commercial space companies. Now, I haven't decided definitely to do that. I'm still in the thinking over mode, and I'm not sure how well it will work. But we may just give that a try next week. I'm going to think about it a little bit more. I also want to give a shout out to my listeners down in New Zealand and give a big old high five for getting that first launch into space. Congratulations, New Zealander listeners. Okay, that's all I have for this week. I hope to have episode 211 up by next Thursday. So long for now.